All right, so on this review here, you can see the answers graphed. If you're in Miss Wilburn's class, you might not have this one on there, but basically just your basic things, a line, parabola, move left 3, reflected over the x-axis. Make sure you have your points on there. Parabolas go 1, 1, 2, 4, and so forth. So shading on this one, everything above, solid line because the equal bar. Down here, the only thing kind of new added right now are these x to the third functions, or these cubic functions. So your basic cubic function looks like this. You plug in some points, 0, 0, 1 to the third is 1, 2 to the third is 8, and the negatives are negative. So basically you get a picture looking like this if you graph these points. So it could have up to 2 turns, but this one's so simple that it doesn't because there's nothing else after it. So this is moved over to the right too, same shape. So you basically have the center point. You kind of have one up in this corner, one up in that corner, and then you kind of like draw a little snake graph. This one's moved up too. Same picture. All right. Over here, so I'm just going to kind of go over these answers and talk about them. Let's look at these two right here. So because your degree is 6, you're going to look for 6 solutions when you solve an equation with that in it, equal to 0. And you can have up to 5 turns on the picture. You might not have 5 turns, but up to. All right, this is kind of left over from last chapter. Whenever you have a solution with an imaginary number or a complex solution, you're also going to have the conjugate. So you just change the middle sign. Just like when you have x equals 2i, you also have a negative 2i because you're doing square roots to get that. Or like this one would come from the quadratic formula. Okay. These two here, standard form of a parabola is given, change it to vertex form. So remember, you want to group these two separate. Then you take half of 6, which is 3, and square it and get 9. You're adding 9 here, so you're subtracting 9 out here to counteract it. And then you're factoring this, x, put the minus, and whatever you use to square to get 9. Right? And then clean that up, you got your vertex right there. Write 3 down 7. Okay. Right, over here, if you're going to use synthetic evaluation for evaluation, you line up your numbers, you put exactly that number here, and whatever you get for the remainder is your answer. So negative 2 produces negative 71. All right, these next two, is x minus 1 a factor? And this got kind of messed up here, but it has all the parts, nothing missing. So do your synthetic division. It did not come out to 0, so it is not a factor. And over here, the third degree polynomial has these zeros, so it's going to have x plus 3, x minus 2, and x minus 3, not this one, as factors. All right, these two, the real roots of this equation, so you have 2 options. You could factor it. These are perfect cubes, right? This has a root of 3, and this one right here has imaginary roots if you go and test it out. Actually, a third way I could think of is you could graph this. If you graph this problem, it's pretty far down, but basically it kind of looks like this, move down 27 right here, but it's going to cross up here at 3, all right? Also, you could move the 27 over, and just like you do to get rid of a square root, you do a cube root to get rid of a cube power. Now, cube root doesn't have a plus or minus, so your answer is just 3. But like I said, you could graph it and just see one x-intercept also. And behavior, so we have an odd. Odd is normally right side up, left side down, but this is reversed because the negative. So left side up, right side down. Over here, what are the factors and the roots? So the roots are negative 3, 0, and what's that, 5. So your factors are x plus 3. Whenever you have a plain x, a 0, you get a plain x, and then the other one would be x minus 5. So you can just write them like that. You can put the x in front. All right, divide these. So this is just a normal synthetic division. Get your remainder right here. So remember, you write your answer. It drops down a level. 3 times 3 is 9, add those up to 5 times 3 is 15, adds up to 10 times 3 is 30, adds up to 24. And then you write your answer there, plus your remainder over what you were dividing by. All right. Next page here. All right. So your graph can vary from this one. All right. You need to make sure you have your end behavior as left side going down or right side going up. So I kind of drew that over here to myself. So my zeros, those are my important parts, -4, 2, and 5. So I'm crossing there. So I knew because of this that after I touch the x-axis for the last time on the left, I'm going to go down to a negative infinity. I'm going to go up to positive infinity on the right side. It said that there were double roots at 2 and 5. So that means that as I'm coming up, I'm bouncing off this because it is a double root, and it's going to bounce off here again. So that tells me that I got those two bounces. So I don't really know how high this is, but I know it's bouncing like that. It could be higher, lower, doesn't matter. Going to go through 0, 5, told right there. And then I just have to come back down through -4, and that's it. All right. Over here, factoring. So these have nothing in common, so I'm going to split it down the middle and do my grouping. Take this out, the 3x plus 1 matches, so we're done. Over here, perfect cubes, no GCF. So 4 times 4 times 4 is 64, so I got 4x. Then I got 3 times 3 times 3 makes 27. I square this and get 16x squared. I multiply 4x and 3 together, get 12x, no signs. 3 squared is 9. And then I do my SOAP, right? Same, opposite, always positive. So same sign, opposite, always positive. All right, down here, factoring still. So this guy, it's similar to 21, but it has a GCF to pull out. So it's quite a large GCF, but, oh no, I'm sorry. Never mind. Anyway, no GCF, but I was just thinking of this part right here. So pull that out, a negative, pull the 9 out, 2x plus 3 matches, so pull that out, leaves me with that, perfect squares, that factors more. All right, over here, this is similar to x squared plus 7x minus 8, and you would factor that as x plus 8 and x minus 1, right? But we're just like raising up the powers a little bit. We're kind of increasing this to 4, increasing that to 2. But when you split up the 4 into x squared and x squared, it all turns into the same idea here. So I mean, this is not the answer, but it helps you to figure it out. So, you know, I have -1x squared and plus 8x squared. That makes my 7x squared and minus 8. Well, looky here, I got perfect squares. So, factor. All right, down here, we have this picture, and it is visible to me that 1 and -2 are my zeros. So I put those through synthetic division. It doesn't matter which one you do first, you will come out with this in the end. So if I took 2 x's out, that means I have x squared, x, and nothing. So I need to solve this. X squared plus 16 equals 0. Also notice, I'm looking for 4 answers. I only see 2. So the other 2 must be imaginary. And lo and behold, when I subtract 16 and do my square root on both sides, I get plus or minus 4i. So there's my imaginaries, there's my reals, write them as my factors. All right, last one. So in this problem, you're starting off, you have this, you have your possible rational roots. So everything that multiplies to 3, all the multiples of 3 and all the multiples of 2. So put those in a fraction. So what that means is that 3 over 2 or 3 over 1, 1 over 2 or 1 over 1. That's the list of the numbers that might work in this. So I just tried a few. All right, now 3 over 2, I don't want to try that yet. So I just tried 3 over 1 and 1 over 1. I just tried those, plus and minus. So let's try it. I tried 1. I tried -1. Those came out with remainders. They did not work. But then I tried 3 and it worked. Okay, so 3 worked, and once I did that, I was down to a quadratic. So I had 2x squared plus x plus 1 left over. I could not get it to factor because 2x and x, if I put the 1s here like I'm supposed to, this would make a 2x and 1x. I can't get that with all positives, you know, like these are all positives, so it's not going to add up right. Okay, so we can't factor. So And also, frankly, I shouldn't have even bothered. I don't know why I did, but the answers are imaginary, so I can't factor it. That was actually a silly move. I was just going about trying to do everything, right? So I knew the answers were imaginary, and I couldn't do square roots, so I'm stuck doing the quadratic formula no matter what. So I get -7 for my discriminant. Put that in there, pull it out for my I. There's my two answers that are imaginary. Notice the conjugate, -1 plus I radical 7/4 and -1 minus I radical 7/4. And then 3 was proven earlier right here. And there you have it. All right, bye-bye.